Hello, my name is Rafael Diniz. I will show you today a demonstration of broadcast data transmission using HERMES-Broadcast and Mercury modem. We will use a fountain code for the data carousel transmission. So here in the computer, I will demonstrate first with two radios in the dummy load, turning on and off the transmission to simulate loss of packets. And then I will also show transmission over the air. So now I demonstrate the use of HERMES-Broadcast using RaptorQ fountain codes to transmit data, in this case using dummy loads. So I transmit a book that I will compress before transmitting. Let me gzip, and now the book is with 40 kilobytes, 39,427 bytes, and let's transmit it. Transmitter, let's use Mercury mode 9. Mode 9. And let's enable the transmitter and check the date. Now it's 2:30 and the RaptorQ receiver already received the configuration packet and started to receive the content. Mercury mode 9 at 1260.5 bps, transmit and receiving on dummy loads. We can, for example, simulate a cut in the reception, turning off the transmitter. So when I turn off the transmitter, we can see that there are no packets arriving. The Mercury modem is stuck here, nothing is arriving. So now I turn on the transmitter and the packet should be arriving again. So here simulating again, turning off the transmission, and now turning on again. And now we can see the receiver already have most of the packets for each block, and the file successfully received. So we can do a checksum here to see if what was received was the same as what was transmitted. Let's cancel here, turn off the power, and emit this sync and the checksums match. So we have a successful 440 kilobytes transmission in around, let's see the date, it started at 31 minutes, ended at 37 minutes, so a little bit more than 6 minutes to transmit 40 kilobytes in the dummy loads. Of course, we are using Mercury mode 9, and now we'll go to the over-the-air demonstration. The transmission will be done from Belo Horizonte, here in the top of the map, to this green station in São Roque. They are 500 kilometers apart. And now starting the actual transmission using a simple dipole in the 40 meters band, 6 watts of power. We'll transmit this file, the source code of HERMES-Broadcast receiver.c that has 8161 bytes. And let's start the transmission to São Roque, approximately 500 kilometers apart. In there, also receiving with inverted V dipole, but in there receiving with an icon IC 7100, and in the transmit side using a S-bit X V3. So now we'll transmit using mode 3, Mercury mode 3, which will give us 339 bps per second, and we can see that in the receive side we already have signal coming inside with the SNR greatly varying, and frames are coming through. We can see in the receiver the frames arriving already. We have not received yet the configuration RaptorQ packet that initialized the decoder. So now we can see that we received the RaptorQ configuration packet, and now the decoder is receiving the packets to reassemble the original file using the fountain codes technique. So we can see the packets coming through at 339 bps. So now we're getting close to the end of the reception of the file. We can see in the RaptorQ decoder that we have almost in every block we have already enough frames to decode the file successfully. So let's check. The file sizes are already the same, and now we'll see that the file was successfully received. Let's see the difference between the original source code and the received one, and they match. So the C source code was correctly received, more than 8 kilobytes, and here we can see the file. It's there, all good, and transmitted over the air. Power off. This was the presentation of HERMES-Broadcast.